Hello everyone. So here we are back with another lecture on the topic sliding crank and inverted sliding crank mechanism. So here you can see the slider crank mechanism. Okay, so here this is the fixed link, this is the crank number 2, this is the connecting rod, okay, and this whole thing is the slider. Okay, so link 1, link 2, link 3 and link 4. So in slider crank mechanism, what happens, this is the first, here as you can see the circle, here it is the rotary motion takes place. Okay, so this crank rotates and here the rotary motion takes place, and here in this point you can see this is the slider, that is link 4. Okay, so this slider moves in forward and backward, that is to and fro motion, and it is the reciprocating motion. Okay, so slider crank mechanism consists of two different motions. One is the rotary motion where the crank rotates here, and another is the reciprocating motion where the slider moves forward and backward. Okay, so here we are. Slider crank mechanism, arrangement of mechanical parts designed to convert straight line motion to rotary motion, as in a reciprocating piston engine, or to convert rotary motion to straight line motion, okay, as in a reciprocating piston pump. So the basic nature of the mechanism and the relative motion of the parts can best be described with the aid of the accompanying figure, in which the moving parts are lightly shaded. The darkly shaded part 1, the fixed frame or block of the pump or engine, contains a cylinder depicted in cross section by its walls DE and FG. Okay, DE and FG. Here you can see DE and FG. This DE and FG. Okay, so in which the piston part 4 slides back and forth. Okay, so the small P circle at A represents the main crankshaft bearing, which is also in part 1. The crankshaft part 2 is shown as a straight member extending from the main bearing at A to the crankpin bearing at B, which connects it to the connecting rod part 3. Here this is the connecting rod. Okay, so moving on to the next. The connecting rod is shown as a straight member extending from the crankpin bearing at B to the wrist pin bearing at C, which connects it to the piston part 4, which is shown as a rectangle. Okay, so the three bearings shown as circles at A, B and C permit the connected members to rotate freely with respect to one another. So the path of B is a circle of radius AB. When B is at point H, the piston will be in position H, and when B is at point J, the piston will be in position J. On a gasoline engine, the head end of the cylinder, where the explosion of the gasoline air mixture takes place, is at EZ. The pressure produced by the explosion will push the piston from H position to position J. Return motion from J to H will require the rotational energy of a flywheel attached to the crankshaft and rotating about a bearing collinear with bearing A. On a reciprocating piston pump, the crankshaft would be driven by a motor. Next, we are going to inversions of slider crank mechanism. So, what is inversion of slider crank mechanism? So here it is. Different mechanisms are obtained when we fix different links of a kinematic chain, and the phenomena is known as inversion of a mechanism here. So a slider crank mechanism has the following inversions. Okay, a slider crank mechanism will have 4 different inversions. So here is the first inversion. So first inversion is, this inversion is obtained when link 1 is fixed and links 2 and 4 are made the crank and the slider respectively. Okay, so the here you can see one application. This mechanism is commonly used in IC engines, steam engines and reciprocating compressor mechanism. Okay, so here you can see the first inversion of inverted slider crank mechanism. Here this is the link 1, that is the frame which is fixed. Okay, so here this is the link 2, that is the crank. Link 3 is the connecting rod. Here this one is the link 3, and link 4, it is the crosshead. Okay, so it is the reciprocating engine, first inversion. Moving on to second inversion. Here, by fixing link 2 of the slider mechanism gives second inversion. Rotary engine mechanism or dome engine is the application of second inversion. Okay, so it is a rotary cylinder V-type internal combustion engine used as an aero engine. The rotary engine has generally 7 cylinders in one plane. The crank, that is link 2, is fixed, and all the connecting rods from the pistons are connected to this link. In this mechanism, when the pistons reciprocate in the cylinders, the whole assembly of cylinders, pistons and connecting rods rotate about the axis O, where the entire mechanical power developed is obtained in the form of rotation of the crankshaft. Here you can see the figure of the rotary engine, that is rotary engine mechanism or dome engine. Here you can see link 1, that it is the cylinder. Okay, so link 2 is the fixed crank. Okay, so here you can see it is fixed. Link 3 is the piston, this is the piston, and link 4 is the connecting rod here. Okay, so it is the figure of a rotary engine, which is the second type of inversion of inverted slider crank mechanism. Next, moving on to the third inversion. Here, by fixing the link 3, that is the connecting rod of the slider crank mechanism, we can obtain third inversion as shown in figure. It is used in hoisting engine mechanism and also in toys. In hoisting purposes, its main advantages lie in its compactness of construction, as it allows simple method of supplying steam to the engine, cylinder. The application is, it is used in hoisting engine mechanism and also in toys. So you can see here it is the figure of oscillating cylinder engine, where link 3 here is the connecting rod and it is being made fixed here. So here link 2 is the crank, piston rod is the link 1, and cylinder is the link 4. Moving on to the fourth inversion of inverted slider crank mechanism. Here what happens, by fixing the link 4 of the slider crank mechanism, we can obtain the fourth inversion of slider crank. Here fixing the slider means that the slider should be fixed in position and also should be fixed in respect to rotation. In this case, the cylinder will have to be slotted to give passes to piston pin of connecting rod as the cylinder slides over the piston. Due to this difficulty, the shapes of the cylinder and piston are exchanged as shown in figure below. Here you can see the figure of a pendulum pump, that is here one application of this is the hand pump. Okay, so here you can see piston rod, that it is the link 1, and link 4, that is the cylinder, is the fixed link, which is being fixed at both the ends. Okay, so here you can see the crank, that is the link 2, which will rotate. Okay, it will give rotary motion, and here link 3 is the connecting rod, which is being connected between the cylinder and the crank. So it is the link 3. So this is the figure of a pendulum pump, which is the fourth type of inversion of slider crank mechanism. Okay, so with this we have come to the end of this lecture. Thank you everyone.